Have you ever felt like your recommendations are just stuck in a rut? Always showing you the same popular hits over and over? Well, it turns out there's a hidden bias baked right into the system, and it's especially tough on new music and movies. We're going to break down exactly how it works and how one surprisingly simple fix could change everything.
Right? You know that feeling? You're all set for a new movie night, you open up your app, and the suggestions are either totally out of left field or, worse, just the same stuff everyone else is watching. You are not imagining it. When it comes to brand new items, the system is, for all intents and purposes, just guessing.
And this is actually a huge challenge for platforms like Netflix or Spotify. It's called the cold start problem. Think about it. Without any data, no clicks, no views, not a single rating, how on earth is an algorithm supposed to know if a new song is a banger or if you, specifically, are going to like it?
Okay, so to get around this, platforms use this really clever system. You can think of it like a seasoned mentor training a brand new apprentice. But as we're about to see, this whole approach has a pretty serious hidden flaw.
So here's how it goes down. First, you've got the mentor model. It gets trained on tons and tons of historical data, so it becomes fantastic at spotting what's already a hit. But that creates a bias. It just starts favoring what's popular. Then you have the trainee model, which is built just for new items. But here's the catch. Instead of learning from real people, it's just taught to copy the mentor's predictions. And that's the core of the problem. It inherits that same popularity bias without ever seeing how a single user actually reacts to anything new.
And this quote from the researchers really hits the nail on the head. The very system designed to help us discover new things is actually just learning to copy the biases of the old system. This right here, this is the smoking gun.
So how did the researchers figure this out? How did they prove it was happening? Well, they went full detective mode. They started digging into the data, looking for clues to see exactly how this bias was being passed down from mentor to trainee.
Okay, take a look at this graph. This shows that mentor models bias in action. Along the bottom, you have an item's actual popularity, and going up the side is how often it got recommended. Now look at that crazy cluster at the very top. A tiny handful of items are getting recommended tens of thousands of times, way more than they should be. The bias is undeniable.
And this side by side really illustrates the whole problem perfectly. On the left, that's the mentor's bias we just saw. But on the right, that's our trainee, the cold model. Just look at that. It's not a clean copy at all. The pattern is even more chaotic and distorted. The trainee is trying to copy the mentor's bias, but since it's just guessing, it leads to some brand new items getting insanely over-recommended.
So you might be wondering, if the cold model has zero user data, what is it even looking at? Well, it only has one place to turn: the item's content. Things like the genre of a movie, the description of a product, or even the specific audio features of a song. Essentially, the model learns that certain content features are linked to popularity. What this chart shows us is that if a new, cold item happens to have content features similar to a super popular, warm item, boom, its recommendation count just shoots through the roof. It's kind of like a new indie film suddenly getting pushed to everyone just because its poster uses the same font as a Marvel blockbuster. It's following all the wrong clues.
And the impact of this is, well, it's staggering. In one of their experiments, the researchers found that just 50 brand new items made up over a quarter of all the top recommendations. Meanwhile, more than 1,300 other new items were never shown to a single user. Not once. They were completely invisible.
So the system is basically shouting about a few items while whispering about thousands of others. This led the researchers to a beautifully simple solution. What if we could just turn down the volume?
Now, to understand this fix, we just need one quick concept: vector magnitude. Don't worry, it's simple. Every single item in the system has a kind of digital signature. You can think of its magnitude as its volume or confidence. Items with a higher magnitude are simply louder, and they get recommended way more often.
And you can see that effect right here in black and white. As an item's loudness goes up along the bottom axis, its recommendation count just skyrockets exponentially. The system is only listening to the loudest items in the room and pretty much ignoring everyone else.
So the problem is that a few items are shouting over everyone else. The solution, which they call magnitude scaling, is this really clever bit of math that acts like a sound engineer at a concert. It turns down the volume on those super loud items and, just as importantly, turns up the volume on the quiet ones, giving every item a more equal chance to be heard.
It's a really elegant idea, right? But does it actually work in practice? Well, let's take a look at the proof.
And here are the results. That steep blue line way down at the bottom, that's the original biased system. But all the other lines show what happens after the fix is applied. Do you see how much the curve flattens out? The recommendations get spread much, much more evenly across all the new items. No more shouting.
But honestly, this is the most incredible part. Look at the table. Item fairness, so how diverse the recommendations are, it goes way, way up. The items that were completely ignored before now get a huge boost. And the best part? User accuracy, which is how good your recommendations actually are, barely changes at all. We get a much fairer system for everyone, without sacrificing the quality of your recommendations.
It's a total win-win. New artists and creators get a real chance to be discovered, and we as users get more diverse and interesting suggestions, breaking that endless cycle of the same popular stuff over and over again. So this isn't just some small, nerdy technical fix. It actually points to a much bigger, much more important conversation about what fairness really means inside the algorithms that kind of run our digital lives.
For creators, this means their work isn't dead on arrival just because it doesn't look or sound like last year's blockbuster. For you, the user, it means finally breaking out of that popularity echo chamber and maybe discovering content you genuinely love but would have never ever seen otherwise. And for the platforms themselves, it just creates a healthier, more vibrant digital world for everyone.
This whole investigation revealed a bias that was hiding in plain sight, passed down silently from one algorithm to another. It leaves all of us with a really critical question to think about every time we scroll. What other hidden biases are quietly shaping the choices we're given and the world we consume every single day?